Hello, good afternoon, everyone, and welcome for this final session, the final parallel session of the RTR 2025. We are happy to have you here, despite all the challenges of the day, of course, despite the strike, despite, of course, all being tired for an amazing conference that already took place. And just if we look about this morning, we have very interesting points as well that were mentioned by our panelists. We have seen public transport, shared mobility. We have seen how the integration of those elements in terms of the multimodality. We also looked at mobility hubs and also how the mobility hotels can actually help on the connection points. And let's not forget tourism, which are basically people moving around on specific needs and specific occasions. Of course, the only objective that we have there is to move passengers and to move goods. Now a question to you. Can this complex environment work without a coordinated approach? Probably the answer is not. And in fact, that's why we are here today in this session for the multimodal traffic management. And we're going to look into the door-to-door movement of transport of passengers and goods. And my name is Thiago Tavares. I'm from CINEA. I have the pleasure to also be the project officer of the projects that are presented here. And I'm going to share the moderation role with Vivi Michalaki, and she's the head of ITS and mobility at the National Highways in the UK. I'd like to also welcome those that are watching us by streaming, and also glad to see many familiar faces and also new faces in the room today. So in these slides, you see a little bit of the recent R&I projects focus on multimodal network and traffic management. And if you look at these, maybe you are familiar with some of these projects already, so the ones in the red box are projects that I've just finalized last year. And they actually build the basis, the foundation for all we were working today here. And what is interesting is that if you look at the title there, it was Network and Traffic Management for the Future of Mobility. And that what they easily realized is that, of course, the future of mobility cannot happen without the multimodality aspect. And they have formed the forefront cluster, which became the multimodal traffic management cluster that you have there now. And now this cluster has been enriched with the 3 new projects that we're going to be discussing today, SYNCHROMODE, ACUMEN, and DELPHI. Of course, what is coming in addition to what has done before, first, of course, there's a much more focus on all the different algorithms and artificial intelligence implementation and also machine learning, and how can actually this make easier for passenger goods be transported from one place to the other. And let's not forget different aspects related to this, which are, of course, the governance aspect, how to actually integrate passenger and transport to make sure that the demand is managed when you have peak demands and low demands. And, of course, it includes all the discussions which are related to tourism. So let's think now about the reason why we have these projects here, right? So as you're very familiar probably with the recent developments in the sector, the Commission has recently updated the ITS directive. And it's not a surprise that many of the aspects that will be discussed today are really relevant for the directive, and that's what the directive is trying to facilitate. Of course, if we look at the delegated regulations on real-time traffic management, real-time traffic information systems, and also multimodal traffic information systems, data is key, as well as the requirements of this data to make sure that the quality is there. Then you have the management of traffic and operations. And let's not forget the multimodality and also the logistics aspects. So all of this is only possible if you do have a good governance in place. So let's now move on to the presentations. And first we'll start with project ACUMEN. And for that, I'd like to invite Claudio Roncoli. He's an associate professor at Q Leuven, Belgium, and also the visiting professor at Aalto University in Finland.
Okay, thank you very much, Thiago, for the introduction, and thank you very much, you all, for participating in the session. So I will spend the next 15 minutes or so try to give you an overview of what has been happening in ACUMEN and what ACUMEN is about. ACUMEN is a project that is going to be lasting for 3 years. And our angle, our idea is to try to understand and leverage as much as possible AI, AI as a tool, as a technology for taking more informed decisions in these multimodal aspects. Of course, the main issue we're trying to tackle here is that, of course, multimodality, when we take into account multimodality in management, in transport, this also means that the complexity grows and grows exponentially. So there is, of course, no simple solution to complex problems. So in here, we are trying basically to leverage as much as possible the new technologies that are available. So this is, a research innovation action. We have 16, 17 partners from 9 countries. And these also include some associated partners from Switzerland, besides covering quite well Europe. And we are basically midway, so we just reached our 21st month basically of the project. So we are just a little over the halfway through the completion. So basically the 3 pillars that we have been working on ACUMEN has been basically starting from the data. So there is, of course, a large amount of data which is available out there, which is produced. But only a limited fraction is actually used for traffic management purposes and for managing our networks. And there is, in particular, of course, a lot of issues connected to data and connected to data sharing. And one of the issues that you also identified is that, and it's pretty obvious when we start also thinking of these broader mobility services appearing and private and public operators basically providing mobility, is also the fact that a certain amount of data, large amount of data may pose a threat for security, for safety. There are privacy issues. Think of simply, schedule of someone using taxi services or on-demand services. And of course, this data is also part of privacy, of secrecy for companies. So there is definitely some issues in how we can actually get this data shared and how we can actually use this information. And this is one of the pillars that we have within the project. And the second, I will go into a bit more details later on. And the second pillar that we basically identified is that we also need to improve our ability to make predictions of what is going to happen in the future. There is a lot of tools already available that can make certain prediction in terms of traffic. That's a very much explored area, let's say, in the most advanced traffic management centers. They can make certain predictions, but there is very, very limited understanding in terms when we talk about demand. So we know if in given current condition, if traffic is going to get a bit worse or not, but we don't know where this demand comes from. And we don't know what's going to be demand for the different modes. And actually, this is crucial when we want to assign and provide alternative to the people, to the travelers. And then the third pillar is try to make, again, given that we have this improved knowledge of term of data, in terms of models, predictions, how we can actually make better decisions. When we have these different components that can be, let's say, that are managed in different ways, and understanding if we start, let's say, modifying a certain behavior of one of the components, what is going to happen to the rest, and so on and so forth. So how we can put all these things together. Now, the idea of the project is to have these methodological developments in here. And then as an aggregator, we use digital twin technology. So the idea is basically to have a certain replica of our real system in a digital form. And this can be basically used for retrieving data, running models, and then providing solutions for the traffic managers. Within the project, we have 4 pilots where we try different aspects of the project. Amsterdam, Athens, Helsinki, and Luxembourg, and also here I will give you a bit of details later on. And each of them basically focus on specific use cases where we basically try to explore the different combination of these methodologies to address concrete issues. Yeah, so when I was mentioning about data, of course, this could be in a certain sense, again, a major issue, how actually we can get access to proper data for management. And so, as I said, one major issue basically we had is when you go to mobility operators and you say, can you, well, provide the city with certain data for management, there is always a lot of barriers. So here, basically, the idea is that we use specific technology and specific new methodological developments to try to harness, to gather this data, gather actually important data, relevant data, but without accessing the actual data that is owned by a company or maybe difficult to share. So we develop, well, specific technology. I will not go into details, but so that through artificial intelligence tools, we can basically capture a certain information which is of interest for management from the data, but without actually collecting or sharing in any way the actual data. And that's a quite well, significant, let's say, improvement we can actually have, because in this way we are basically able to get to maybe not full access to certain important information, but at least getting something more than what we actually can get nowadays. And of course, when you also have a large amount of data from different sources, you can start doing and combining this data so to gather even more relevant information for your management tools. And for example, I will also describe it soon for the use case of Helsinki, but we have an interesting case where we have a part of the network which is typically not very crowded, but at specific moments it actually gets is a part next to a big ferry arrivals. And whenever this ferry arrive, it creates all the time road congestion, but also public transport crowdiness. And that's something that nowadays it's done controlled almost manually. So people were just traffic operators are essentially just changing traffic plans based on some very basic thresholds. For example, ignoring what is happening on the public transport, so not providing alternatives to people. And so we, for example, use specific tools for improving our capability of estimating the crowdiness into vehicles. And then the third part, components about data, which we identify as a big criticality, is also actually having some measures that allow us to better understand when we actually need to intervene in some way. So again, with the current tools, there is not a consolidated method that, looking at the whole picture, basically you are able to identify disruptions. Of course, there are methods again for incident detection. These are there working, but when we talk about multimodality, it's not only incidents. Again, it's also public transport vehicles that get overcrowded for some reason, and that's a big disruption. Or maybe the need for I don't know, a public transport vehicle, a train gets broken. I was talking yesterday to a colleague who was telling a story about this, and there is urgent need of getting some people from a specific place to another one and without using the primary mode. So one important task we're also been working on is try to develop methods for detecting when we have actually these disruptions by, again, looking at the combination of traffic measures, but also passenger measures, experience delay, and so on and so forth. So when it comes to prediction and forecasting, as I said, the special emphasis here is on the modeling the demand. Again, we know we have tools for predicting how traffic evolves, but not really for predicting on any scale, basically, how people are going to move and what are the needs of the people to move. So we are developing methods, again, for those, trying to capture this variation, this daily and within day and day-to-day variation of demand, and being able then to have more accurate predictions of what is going to, what kind of demand we need basically to satisfy in the next 15 minutes, half an hour, 1 hour, and then having also an understanding of what this is going to mean in our transport system if we don't take action, if we take action. And then when we go about management, of course, we can do the main goal here, I mean, is to work on integration of different methodologies, so and how they actually act together. We are working on separate, basically, we're looking into different strategies and what are their implication interconnections, so that we can, at the end of the project, be able basically to get some methodology able to abstract them and have them as part, let's say, of a whole management framework. So that's the idea, and here again, AI is quite important tool that comes in our help, again, thanks to its ability to capture in certain complexity that otherwise is difficult to see. So when it comes to technology, as I was saying, so digital twin is the center, so there is a lot of this definition of digital twin and then a lot of very different ways on how people have discussed and defined digital twins. So from us, the basic idea, the way we picture it is like, think of a computer motherboard, which offers a certain core services, and then you can plug in different type of tools. And these different type of tools, of course, may create different instantiation of this digital twin, but still that can contain the main feature of being able to collect data, process data, and provide, again, could be prediction tool, could be managing tools, could be decision support tools. And so the idea is that we have basically this whole structure of a twin that can be implemented in different cities with a little bit different angle and different combination of tools, so that we can actually address the specific problem that each city has and the specific data that each city may have available or not. So here, the modular structure basically allows us to define this twin. So couple of words about the pilots that we are working on. Also here, as I said, we have a combination of different options that we could actually explore, and we go from for example, Athens, where we have a pilot very much into involving the traffic management center and people working at the traffic management center, how they can actually use these tools with in particular the prediction capability of these tools to take better decisions in the future. So our instantiation of the ACUMEN digital twin in Athens is more about we look at the traffic picture now, we run some tool, and they can essentially, we provide them a tool through which they can basically play with different management actions and see what if I do this action, do this combination of actions, or this other combination of actions, what are going to be the results? And so they can incorporate this into their, let's say, decision-making process when there is some mobility problem to be addressed. When we go to ACUMEN, to Helsinki pilot, we look at the different combination of, again, this multimodal area with many different mode of transport, how we can actually coordinate traffic in that situation. So how we can actually redirect people through one mode or another, depending on what is basically getting more congested or more problematic in another case. And in Luxembourg, finally, we are working on on-demand shared services, in this case, a shared van, where we basically try to incorporate this part of on-demand interconnected with the other different systems that are already in place, like train system, etc. So, well, to conclude, we are not at the end of the project. We are still halfway, so we don't really have final results. But the main, I think, so from our perspective, so the main improvement we are looking into is really improving the door-to-door experience of travelers and reduce travel time and reduce congestion from their side, but also reducing the efforts for the traffic managers to implement these kind of actions and to make them actually operational and make, let's say, their decisions simpler and more effective. And that's it from my side. Thank you very much.
Thank you very much, Claudio, for the presentation. And I think you touch upon very interesting keywords as well. I think we hear quite a lot these days about digital twins, artificial intelligence. But what I really found was quite interesting as well is your approach into how to deal with data. There's a lot of discussion on how to make sure that data is private. And I think you're looking into this model training without really accessing the data, can something that we are really looking forward to hear in the next steps of the project. Now we're going to move to the next project, which is SYNCHROMODE. And for that, I would like to invite Dimitris Zanis from Research Associate at SURF. The floor is yours.
So thank you, Thiago, for the introduction. Thank you, everyone, for joining this last session of the RTR conference. To be here means that you want to learn and see the progress of those projects in this field. So SYNCHROMODE, as you know, stands for the Advanced Traffic Management Solutions for Synchronized and Resilient Multimodal Transport Services. In a nutshell, let's say the project overview is the following. The project consists of 16 partners. Those partners come from 6 different countries. The project falls under Research and Innovation Action, as you already know, and the duration that it has is 36 months, started on May 2023, and we are halfway, and the expected end of the project is by the end of April 2026. Moving to the objectives and the targets of the project, the overall goal of the SYNCHROMODE project is the development and the implementation and assessment of the SYNCHROMODE toolbox. The SYNCHROMODE toolbox practically is based on the objectives that I will present you in a while, plays the role of a traffic management tool as well as an assisting tool to the existing traffic management systems, and also the solutions and the developments that consist this toolbox are able to be provided to as standalone solutions and tools. So to begin with, at the first we have as a first objective, we have the development of an advanced multi-actor cooperation and governance model through which we will be able, let's say, to facilitate the multimodal mobility service operation needs as well as the needs of the multimodal traffic management. A second objective is related to the development of new interoperable solutions for data gathering, harmonization, fusion, quality assessment, which is not mentioned at all, although that we have a vast variety of data available, as well as the analysis of those data. Then another objective is to utilize different simulation softwares and solutions like EMSAN and SUMO, through which we can have an extended, let's say, simulations, both offline and online, for assessing different scenarios, a variety of traffic state conditions, and also having the ability to utilize the capabilities that are available through the use of CAV technologies. But you will say that all these objectives and targets that the project has may be a wish list, but if we, as I will continue with the presentation of the results that we have achieved so far, you will see that, yeah, at the end it's not the case. So, by the early stages of the project, we have tried to finalize all the use cases that are related to the 3 case studies. In total, we have defined 15 use cases. 9 of them are related to the Thessaloniki case study, 4 of them to the South Holland case study, and the last 2 to the Madrid case study. In a very brief, let's say, way, the focus of the Thessaloniki case study is more on the resilient multimodal traffic management, where we would like to tackle recurring congestion, the impact of both planned and unplanned events that are occurring across the network of the city of Thessaloniki, and provide at the end a more coordinated and also a more multimodal traffic management perspective in the city. Going to the South Holland, more or less the focus is the same, but here the case is that we are looking more on the seasonal events that are occurring at the region, for example, the Kekenhof flower exhibition, or during the sunny days where the demand leading to the beaches is quite huge. And also to assess and define multimodal and novel multimodal traffic management strategies in cases where we have extensive large-scale roadworks that taking place due to the aging of the physical infrastructure. On the other hand, regarding the Madrid case study, the focus is more related to the coordination between the passenger and freight flows and how we can synchronize, let's say, those different modes of transport. In parallel with the finalization of the use cases, we had 2 distinct rounds of local co-creation workshops that took place. Through these workshops, we were able to validate both the user needs as well as the system requirements for the SYNCHROMODE toolbox itself. And in order to have, let's say, an active engagement of the local stakeholders, we utilized a gamification approach, so to have the active participation and extract the needed information in a, let's say, novel way. Besides all those things that we have done, also in parallel we have worked on defining a new governance model, and this model is practically has its core and its basis on the Socrates 2.0 paradigm. Regarding now data gathering, fusion, and analysis, here we are working both on tools as well as on methodologies. The first thing that we have identified is that for sure we have to define the common place through that we will facilitate practically the data exchange between the partners of the project as well as of the local stakeholders for the 3 case studies. So for that reason, we developed the SYNCHROMODE data exchange repository platform, which is available online, but you can access the information or the data that are included there by asking for being registered. Then, another development that has already took place is related to identifying a novel both travel and traffic pattern analysis framework by utilizing raw FCD data and creating and extracting practically vehicle trajectories from those information, giving us the ability to identify the exact routes the exact routes that the travelers follow along the network as well as during a variety of events. Then, another, let's say, tool that we are in the process of developing is related to the identification of roadworks impact. Here we talk about for a data-driven methodology where we are utilizing historical data and we are able to identify the travel patterns and how the users will react or how they will change, let's say, their typical route that they are followed based on different interventions or roadworks happening along the network. And finally, another tool is related to estimating in the future, future traffic states, the demand for the DRT services. Then, moving to the methodologies, as it is already mentioned, we are working on defining a novel data quality assessment methodology, as well as including in this approach some imputation techniques, in order to assess in real-time conditions the data that we receive from field, like loop detectors such as volume, speeds, occupancy, or even from service providers like travel times and speeds along the segments of the network. Also, another, let's say, innovative methodology is the estimation of the demand regarding logistics, as well as the estimation of delivering those parcels to the end users. Finally, besides, let's say, this estimation regarding logistics, we have also included aspects regarding public transport services, both for the operational perspective as well as for the planning. In that case, we have defined KPIs for assessing the level of service of public transport, the DRT services along the different areas of the cities, as well as real-time calculated KPIs for assessing the performance, the delay of the public transport, and things like that. Last but not least, here, as you see at the last point, we have a methodology regarding the identification and characterization of bottlenecks and disruptions. In that case, we are working on utilizing historical traffic data and event data to identify the traffic patterns that lead to different types of disruptions. For example, car accident, or specific weather conditions, or even planned roadworks. Moving now to the digital twin part, here we are utilizing both simulation techniques as well as optimization techniques. The first aspect is that we have two types of simulations, the offline one and the online one, both with different, let's say, scope. The offline simulation is utilized in order to do some planning, to assess defined traffic management strategies, and see their impact under different traffic conditions. The online simulation is utilized for operational purposes, as it is mentioned also by its name, so as to assess in real-time conditions the impact that the current state will have in the next minutes in the network. Continuing, as you may see, we have a sumo driving and traffic simulator through which we want to engage the end users within the process of traffic management and assess how they will react under different traffic conditions, so to receive a more realistic feedback about from the user perspective. And then we have, as already Claudio said about ACUMEN, we have real-time traffic state predictions where we are utilizing a variety of data. Travel time, speed, data from loop detectors, information about weather, planned events, in order to make a more accurate prediction about different time horizons. For example, 5 minutes, 15 minutes, or even having a general, let's say, understanding of the upcoming states for 30 minutes or even to an hour. Then, by combining the knowledge gained from the identification of the patterns that lead to different types of disruption and also the results from the traffic state prediction, we will be able to, let's say, characterize those future states by identifying the potentiality that there will be for a specific type of event to occur within the next couple of minutes in the network. Besides all of those, we have the synchronization and coordination of both public transport services with DRT services, and also we put in play how parcels can be combined with those two services, and let's say at the end have also the freight on transit aspect included. Another optimization and digital and simulation methodology that will be, let's say, developed and assessed within the project is the optimization of the planning processes from the different types of roadworks. For example, if a municipality decides that they will follow a specific approach to implement a roadwork, we can assess how this planned roadworks will affect the network, which will be the impact, and also by optimizing these steps, we can alter the series of the different actions that should take place. Then we have in the simulation, the assessment of a variety of CITS services, such as glossa and signal priority, as well as a variety of traffic signal control measures, such as max pressure, in order to assess how these technologies and these services can affect and provide, and which are the capabilities for real-time traffic management. Then we have the automatic selection and recommendation of interventions, an AI-assisted tool which will combine those different, which will combine all those information collected and estimated, so as to recommend to the traffic management operator the optimal traffic management strategy that should be implemented or activated based on the prevailing and predicted traffic conditions. And last but not least, we have methodologies assessed regarding the network load balancing by utilizing the abilities and technologies provided by CAVs, as well as the social routing aspects, where we will inform accordingly the travelers about the traffic conditions and the alternative routes. All those different technologies, methodologies, solutions will be incorporated, as already said, to the SYNCHROMODE toolbox. Currently, as we are in the, let's say, halfway of the project's lifetime, we have already designed the architecture of the toolbox. We have defined the different user interfaces. We are in the process of developing, so leaving the mock-ups and having, let's say, the final outcome. And we have defined also the needed databases, the data exchange and the APIs that are needed to accommodate the communication between those tools and the front end, as well as we are working on the initial plans regarding how we will test and validate the results through the 3 case studies that we have in place. Then, moving to the dissemination and exploitation, I will focus on the main aspects that we have already achieved. We are active members of the multimodal traffic management cluster, along with the 4 already completed projects, as already Thiago said, and with the other 2 ongoing ones, I mean the sister project of ours. We have prepared the multimodal traffic management cluster roadmap regarding how we are envisioning multimodal traffic management for 2030 and beyond. We have participated to a variety of dissemination events where we have presented both the scientific as well as our technical results. And for this year, the upcoming events that we aim to be active and participate are by having a special interest session at the ITS Europe, at the Traffic Management Symposium in Athens, and as well as in the UITP Summit. Then, before close my presentation, moving to, let's say, medium and long-term impacts of the project, we expect to have, let's say, at the end, achieved our goal by including in a more active way both AI and predictive analytic tools in the multimodal traffic management domain. And by that, as it is a chain of reaction, by optimizing the traffic management strategies, that means that we will be able to lower the emissions, we will be able, let's say, to have even lower travel times, and at the end, the cost efficiency will be even higher. For the long-term aspect, we believe that by having this SYNCHROMODE toolbox in place, and by maintaining and utilize it for sure for the majority of the use cases and test it in real conditions, we will be able to have at the end a seamless multimodal mobility, and also again achieve even lower emissions and a better decision-making approach by migrating from reactive traffic management and multimodal traffic management to active and even proactive traffic management. That's all.
Thank you very much for keeping the time. We really appreciate it, and thank you for the very interesting presentation. What I took note here, of course, is that your really objective to try to optimize the multimodal traffic management, including AI, and also it was very interesting that you also at the end you mentioned what's the impact of it, because in the end, of course, just because you improve the system, you actually reduce the travel time, and consequently, there is a reduction in the emissions. So we should always keep in mind how important the traffic management also is in this context. And let's not forget the governance part, which I'm sure that the 3 parties will work together also in trying to see how we can find common solutions for those. Now we move to the final presentation, which is about Project DELPHI. And for that, I would like to invite Sofia Coconetti. She's a researcher and scientific project manager at the Institute of Communication and Computer Sciences from Greece. The floor is yours.
Okay, thank you for the introduction, Thiago. Good afternoon, everyone. First of all, I would like to thank you for being here at the last presentation of the session. And over the next 15 minutes, I'll be taking you through DELPHI project, its key objectives, achievements so far, as well as its expected impact. First of all, we will see some key facts regarding DELPHI project. DELPHI's full title is Federated Network of Platforms for Passenger and Freight Intermodality. It is an Horizon Europe Research and Innovation Action project on the topic that focuses on combined passenger and freight transport. Its duration is 3 years. Its budget is approximately 5 million. And the project coordinator is ICCS, the Institute of Communication and Computer Science. DELPHI's consortium consists of 16 partners plus one associated partner and one affiliated entity from 8 EU and associated countries with a shared vision to address the growing challenges of combined passenger and freight mobility. In particular, DELPHI's vision is the strategic integration of passenger and freight transport in a single system, working towards integrating sectors, harmonizing data, and leveraging advanced methodologies to transform transportation systems for a sustainable future. DELPHI evolves around 3 pillars. The first one is governance and ecosystem specification. The second one relates to architecture, data, processing, and optimization. And the third one is DELPHI's validation activities through realistic pilot demonstrations. Regarding DELPHI's objectives, one of its foundational aspects is to establish new governance models and regulatory schemes. DELPHI also focuses on the development of multimodal passenger and freight transport network of platforms. We will develop AI and machine learning-powered optimization frameworks for passenger network and traffic management. Another objective of DELPHI is the validation of its solutions through the 4 use cases and simulation-based analysis to ensure feasibility and effectiveness. And last but not least, it is the aim to ensure compatibility with EU standards and policies so that DELPHI contributes to existing standardization efforts, making it easier to maximize DELPHI's impact. DELPHI's federated ecosystem will be evaluated in real-life settings through 4 pilot demonstrations. These are located in Spain, in Madrid, in Greece, Attica and Mykonos, and in Romania, in Cluj-Napoca. In summary, the Madrid use case focuses on multimodal transport for last-mile delivery of parcels from the e-commerce channel, leveraging the Madrid Metro network. The key enabling partners for this use case are Metro Madrid, DHL, and Koiki. The Attica use case examines ways of optimizing freight and passenger traffic models and data sharing frameworks. It takes advantage of the highway traffic and relative public transport freight capacity. The key enabling partners for this use case are Attica's Diadromές, which is the Attica Highway Road Operator, and Stasi, which is the Authority for Public Transportation of Attica. Mykonos use case focuses on integrating passenger and freight models and data sharing frameworks. In this use case, the fleet of transport network will be utilized for freight transportation between main hubs and interest points, such as the port, the airport, and Mykonos city, during peak touristic periods. The key enabling partner for this use case is KTLM, which is the public transport of the island, in cooperation with the port and the airport. And the fourth use case focuses on data sharing and relevant governance framework in the Cluj-Napoca metropolitan area. It is based on the creation of a data space that is compliant with the standards of the IDSA, the International Data Spaces Association. The key enabling partners for this use case are NTT Data Romania, MCN, the Municipal of Cluj-Napoca, as well as CTP, which is the public transport of the city. Moving on to DELPHI's results. We are still early in the project's development to have tangible results to link with DELPHI, but what we have achieved so far includes the completion of the use cases design. Actually, the respective process flows per use case are available at the official project's website. We have also been participating in the multimodal traffic management cluster for the promotion of results of traffic management projects and the generation of a relative roadmap. Actually, we have some printed material here for you. We have also generated a combined passenger and freight traffic governance framework, including 21 tailored recommendations. The first step towards the development of this governance framework was data collection and analysis. To this purpose, we used two main sources. The first one was working sessions per DELPHI pilot that led to the co-creation of the AZIZ and to be setups associated with each pilot. These were also depicted in the system diagrams at the top of the slide. And the second main source was the DELPHI questionnaire that was developed during our Work Package 2 activities and was addressed to the advisory board members, the Frontier Project Cluster, as well as to consortium partners. And it was focused on the following critical aspects: on multi-level governance of urban mobility, on stakeholder roles and engagement, and to policies related to urban mobility for passengers and freight. The aforementioned actions resulted in the consolidation of 21 tailored recommendations that constitute the backbone of DELPHI novel integrated mobility governance framework. In short, we refer to it as DENIMGov. It includes, among others, the following key areas: data interoperability, the development of a shared vision and collaborative business models, harmonization of regulations across sectors and jurisdictions, as well as to smart contracts and dynamic data sharing protocols. Anyone interested in further details regarding DENIMGov is welcome to reach out at any time. DENIMGov is going to be validated through the DELPHI pilot implementations and will constitute the suggested framework for DELPHI Town. DELPHI Town is a concept of operation based on the assumption that all 4 DELPHI use cases take place in the same city. It explores interactions required between the various transport means to achieve seamless door-to-door mobility of passengers and freight transport. Now, continuing on DELPHI's results, what we have achieved up until now also includes the completion of drone flights for the gathering of real-time traffic data, the deployment of sensor and camera network for data collection at junction points, and we have in general acquired the required data sets for the development of the optimization models. Regarding the project's expected impact, it focuses on 6 main goals. The first one is the improvement of multimodal transport network and traffic management. The second one is resilient network-wide data exchange and integration of data management systems to allow dynamic and responsive traffic management. The third one is the enhanced prediction and resolution of network bottlenecks with emphasis in safety, security, and overall performance. The fourth one is the development of innovative tools and services for optimizing mobility flows of passengers and freights, resulting to significant reduction of emissions. The fifth one is the introduction of new governance arrangements. And of course, number 6, the high market adoption and transferability of DELPHI solutions. Oops, I forgot to change the slide, sorry. That would be all from my side. Thank you very much.
Thank you very much, Sophia, for the presentation. We are very pleased to see that you really focus also on this part of connecting the transport of passengers and also looking at demands and also how you can take advantage for also transporting goods. I think that's something, an area that we don't see much development. It's a big challenge that we see already projects facing. So we're looking forward for that and also to really see how the Delphi city will look like. I think that's something everybody is looking forward to. So now, to continue with our session, we're going to have the discussion part. I'm sure you have some burning questions on your mind, and I would like to invite Vivi Michalaki to guide us on this.
Excellent, thank you. Thanks for all the presentations. I think we all agree they were absolutely fascinating. I find this topic particularly within our area of interest, especially because of all the change in environment going on at the moment and the new energy sustainability targets we have. Safety still a massive issue, but again, how we manage on a multimodal level, still we definitely haven't cracked it. So I look forward to also having everyone coming back next year to see what the results closer to the end of the projects will be. I'm just wondering to start with, are there any burning questions? I have got a couple to begin the conversation, unless don't see any hands just yet. So everyone spoke a lot about data, and I think we all agree it's a massively valuable tool, but also a huge challenge in terms of how we manage and how we make sure that we actually collect what we need for the reasons that we need. And I think, Claudio, you did mention we have lots of data and information, question mark, I suppose, that we collect. And I was wondering, for all three projects, how did you specify what data you need, what information you want to take out of that data, and how that would feed into the models that you're all developing? So that applies to all three. Whoever would like to make a start? Claudio, yeah?
Can you hear me? Yeah. Okay, thank you very much. This is a very interesting question. And as I mentioned, so data for us has been central when started thinking of the project and designing the project. I think here, of course, what we clearly realize is also that there is not a very common data availability through the different areas, to the different needs that one can actually may have. And that's also where it comes, our idea is that you can actually collect probably roughly the same information also from very different type of data sources may be available. So what we did, at least in our project when designing it, was really starting from the very beginning, understanding and mapping for the different cases we wanted to tackle, very different use cases, and also for different systems, what actually was available out there. And there has been quite a few iterations, but again, from my side, I mean, as an engineer, here I also say, okay, sometimes what you also realize is that you may not always have the data that you want specifically, but through combination of other data, you can also get the same information. So I would definitely here try to focus more on the information that you actually need for running this model. And then what we try to do is to find tools so that from the available data, we actually collect that information that we actually needed. So I would put a bit more stress on that. I don't know if you want to add something.
Yeah. Regarding, let's say, the SYNCHROMODE project, the identification of the data needs derived, based after having identified what we want to do, finalizing the use cases, engaging the local stakeholders from which we can extract those information, or from those at least that they are willing to share this information with us. Also taking into account the previous knowledge or experience that we have from other projects, we had, let's say, the ability to persuade or at least approach those stakeholders and make those data available that we will need, at least to achieve or utilize, let's say, those data that we need for the development of those tools and assessing the results. And also, another point is that let's say, for the case study of Madrid, where we have the logistic part, this was a tricky one. That's why from the beginning of the project, we have included, let's say, the respective partners like City Login and Riva, from which we were able to receive the needed information. So we had, let's say, a proactive approach from the preparation of the project.
Excellent. Thank you, Dimitris.
Is it working? Yes.
Yes.
So being proactive was also the case for DELPHI project. What we did was to include key end users in the consortium. We also secured some letters of support from external stakeholders during the preparation of the proposal. And we also tried to identify possible gaps and try to cover them within the project scope, such as the drone flights and sensor installment in the Attica use case.
Okay, thank you. And Dimitris, you mentioned CAV in your presentation. Again, it could apply to all three projects, but in the evolving, I suppose, environment of bringing more of that level of connectivity and automation into vehicles, and I'm not necessarily thinking about traditional vehicles, it could be also shared mobility. How do you expect that to change the approach of the project, maybe not within this phase, but in future phases too?
Sure. Also, let's say, the aspect of CAVs will be examined only in the simulation environment, in a simulated environment, due to the unavailability of this technology in the real world. But the expectation from the implementation and assessment of this technology is that we will be able, let's say, to guide or to provide even more accurate and advanced information to the travelers, so we can coordinate and, let's say, balance the network in a more efficient way, and even more earlier than based on the expectations that we have about the future traffic states.
Would you say it as a two-way communication then? I'm also coming, I suppose, from a road authority point of view, and what we would like to need to know, and what information we would need in that kind of traffic management environment. So how would you see that working in a two-way kind of cooperation, let's say, between the model, CAVs, or CAM, I suppose, as a concept, and potentially the end road operators?
The road operators, at the end, they will have a greater, let's say, knowledge about the absolute status within the network. They will have, let's say, an additional data set through which they can retrieve information about the status and the conditions, and also a factor through which they can, let's say, moderate or switch and shift things within the network. I mean, besides impacting the conditions by changing traffic lights or providing information through VMSs or CATS services to the drivers, they will be able, let's say, to have another tool through which they can provide a useful impact within the network.
Okay. Thanks, Claudio. Yeah?
Yeah, can I add a bit here? Well, I'm not going to start talking too much about CAVs. I can spend a few hours, but I think that's definitely one important angle. I mean, CAVs and other emerging technologies as well, but CCAM in particular, what we definitely are going to expect is that they may be able to change drastically how the traffic system currently operates. So I think if we don't have this bidirectional cooperation, we are going to be in huge troubles in a not-so-distant future. So there should be quite clear capabilities in the future traffic management systems to capture whatever these vehicles are doing, but also to be able to influence in some way their behavior within the system. So if this is not happen, I see as a big problem. And that's now, if we think about multimodal, this problem is not only about cabs and vehicles, but also about all the different ways that we have to nudge people to, I don't know, Google Map style apps or something else. So these big technologies can actually change the behavior drastically. And if we don't have these in some way to be in a dual communication, then that's going to be a big problem.
Thank you, Claudio. Sophia, is there anything you would like to add in that space for now? No? Thank you.
Covered.
Do I see some hands already? Just having a look. Yes. Oh, yes. Vasilis. Sorry, I'm not sure which one was first. It's easier with Teams. Yep. If you could please briefly introduce yourself.
Yes, thank you. My name is Terios Mitoulis. I work for the University of Birmingham. I'm a professor there. So that's all good and great research. Thanks for the presentations. I'm just wondering, how do you deal with emergencies? Is this part of your frameworks? Is there like a vision to connect this to, flood resilience? How do we recover our networks after extremes? Are we doing something proactively? Are we doing that reactively? What's the plan to connect potentially two silos here in Horizon? The people who are dealing with the resilience of infrastructure and the people who are doing mobility like yourselves. Thank you.
Thank you.
So if I may, within the SYNCHROMODE project, and specifically in the Thessaloniki case study, we have a specific use case focusing on how we can, let's say, manage both planned and unplanned events. And for sure, what you are mentioning is more related to unplanned events where we have extreme weather conditions and things like that. An initial, let's say, approach that we will follow and will implement within the project is that we will assess, let's say, the impact of those events within the network. And by also combining these data-driven methodologies where we are able to extract those patterns or how those patterns we can alter by providing different measures, we will be able, let's say, to assess a variety of traffic management strategies that can be, let's say, activated and implemented even proactively by taking into consideration that we will be able, let's say, to foresee that in the next 15 minutes, in the next hour, combining a variety of data sources, the potentiality of extreme weather event to happen and affect the majority of the network is there. So we will be able, let's say, to proactive and inform traffic in a very short amount of time.
Yeah, and we have, let's say, I think we follow quite a similar approach in ACUMEN. So also in our case, we have, this case is mostly covered, for example, in the case of Amsterdam, where we look at this major disruption that happens when these tunnels get blocked or bridges get blocked. And in our case, for example, we are building a tool, which we call it a stress test generator, which is basically in a semi-autonomous way or slightly guided way, trying to build possible disruptive scenario into the traffic system, in our case, and then through simulation, trying to figure out what kind of actions we can take in these different scenarios. And that, again, it's mostly focused on these unpredicted events or major events, and that, again, can guide traffic managers to take a set of different combination of actions to address those kind of problems.
Thank you.
Would the moderator allow me one quick follow-up?
Of course.
If we have time, thank you.
Yeah.
So the second question is, well, that's one thing, weather conditions, that's fine. It might take a couple of hours to recover from that. But I was referring to something more serious, extensive, and impactful like an earthquake. Thessaloniki is earthquake prone. So have you thought of scenarios where extensive disruption happens? For example, having buildings that are collapsing, having parts of your roads, bridges, tunnels being damaged, which means that you cannot use them anymore. So it's not a matter of, oh, let's just wait for the water to be drained from your tunnel, but rather, what are the alternatives if your bridge or tunnel or central part of Thessaloniki that has many bottlenecks? What are the alternatives there? How do you react to that? Is there a way to make your system more resilient based on your methods? Perhaps not a question, but I'm happy to follow up during the break. Thank you.
Yeah, no, that to us, we didn't look at, we don't plan to look at resilience as such, as a topic, but to me that can be, again, incorporated in the same solution space that I was mentioning before. So for us, for example, we rely on these simulation tools for making possible forecast and prediction of what's going to happen. So for me, the difference between, again, something that dissolves in a few hours or not is just that in the simulation tool, we need to be able to implement and see what happens if, for example, a link, a road, a service is not available. So in my opinion, as long as we can model and capture this to happen in our, let's say, prediction tools, then we can, I'm not saying solve the problem, but at least provide solutions that could help mitigate the problem.
Thank you. Vasilis, I think. Oh, yeah.
Hello, thank you for the presentations. I'm Victoria from ROI. I have two short questions. One is if do all of the projects consider door-to-door transport at an urban scale? Because in my head, door-to-door is from the sender to the recipient, and especially in the freight sector, when we say from the sender to recipient, it doesn't mean like I transfer something, for example, from the port of Mykonos to the airport of Mykonos or to the sender. That was just an example. And the other question is more specific. Did you consider any...
Sorry, before you move to the second part, can you just restate what you firstly asked? Because I didn't catch the start of your question.
Basically, when we say door-to-door, we mean from the sender to the recipient. So, for example, in the case of passenger transport, that means that, for example, I live in a small village in Greece and I want to be transferred to Crete. That's the door-to-door, from where it starts to where it ends. But I notice, if I don't miss something, that the projects have focused in urban scale, door-to-door. If that's what I wanted to confirm, if there was another approach considering door-to-door in a larger scale, which is more correct in terms of at least freight transport.
We focus, we have 4 different use cases. Each one focuses on different parts of the door-to-door mobility. But they mostly focus from the main leg after the product supplier to the last mile delivery.
Yeah, I suppose that this goes back to the point of how wide do we go with the area of influence, and are we working on a potentially national level, taking into consideration highways, other parts of the road network outside the urban environment? So is this where...
National and international, I would say.
Yes, yeah, of course, yeah.
Yes, we're still working on it. We just completed the design phase. It looks promising, but we will have to catch up next year to see.
We'll be waiting impatiently. And the second question is if any of the projects considered railway crossings as a disruption at the points where they intersect with the urban motorways, if there was a disruption.
Is it?
We don't. DELPHI
Yeah,
doesn't.
I think it's an important disruption, like maybe the next level of the projects or in the next project you will join. It's something that the traffic management centers care a lot because sometimes it would take you like 1 hour waiting for a train to cross the road.
Okay. We'll keep that as a...
Yeah, it sounds like you've got some experience in the area. It might be worth sharing more after the session.
Yeah, why not?
Thank you.
Thank you. I have a very technical, I'm sorry for that question, mainly for Claudio. I was triggered by the federated learning point that you have. I don't know if the audience is aware, but federated learning is when it's a Google term, starting from Google, when you do the training of the AI model at the edge, at the handheld edge, so that you don't have to send large amount of data or private data to the cloud or whatever. So I wanted to ask you if the case that you look is that, let's say, versatile, that you need to retrain and retrain the model at the edge, or one simple training can do the work, and then you just do the machine learning, you just use it. And if you have an answer on that, how often, I mean, you do the train at the edge, and if you have compared it with other traditional training schemes, like at the edge or at the cloud or whatever.
Well, that's quite a technical question indeed.
I was apologizing.
Yeah, no, definitely. Honestly, well, it's one other partner that is doing that. We are indeed using this technology that has been, well, taught by Google. So the point is indeed, so we are now, we had different options to decide, and we are definitely doing the training at the edge, and then share parameters with the central node. That's what I can tell you here. But if you want more details, I can put you in contact with our partner that is actually doing the actual implementation of that. And they can maybe provide you with more details.
Thank you, because it's something that we also do in a couple of our SICAM projects. It's very interesting in specific scenarios, of course.
Okay. Yeah, we can talk later.
Hi, I'm Angelo Samditis from ICCS and also chairman of Vertico. So from a technical question to a more high-level question. So more and more we are discussing about integrated transport systems, okay? So how we can put all elements together. So this system of systems idea of having one integrated transport system, of course, looking on passengers and goods at the same level, it's one way to do so, but not the only one. Everything you discussed today, like traffic management, data, AI, digital twins, all of them are elements towards this direction. Having said that, also, let me take the opportunity to inform you, those of you who don't know, that we are organizing in Athens, end of June, 29th of June, the symposium, international symposium on advancing traffic management. So maybe we can also discuss there some of your findings. But my question is, this is a very nice vision, and all these tools and all these elements are quite important in order to achieve it. But what are the challenges that you see? What are the difficulties you see? How realistic do you see that at the end of the day, to have one integrated transport system? Because, of course, obviously, you cannot have just AI or just digital twins or just traffic management models. All this needs to work together.
Thank you. Not an easy question.
Sometimes technical questions are more easy.
To answer, if I have to provide, to say a yes or no at your question at the beginning, yes, I would say no. We will not have at the end one integrated solution or system that will do everything. But as you may see, all those three projects have, let's say, commonalities. We are working more or less on the same, some of the tools or methodologies that we are working are the same. Probably we are utilizing a different, let's say, source of data or having different parameters at the models that we are working on, but more or less we have the same, let's say, aim to develop the same tool like a prediction model or something like that. So yeah, I think at the end, all those developments are taking place among us will assist in a different way the existing tools and will enhance at the end the capabilities that the existing tools and systems have right now. So yeah, the combination, for example, you can, let's say, take the prediction model of ACUMEN with the decision support system and logic of SYNCHROMODE and combine it at the end with the freight and passenger combination of DELPHI and have a more integrated, let's say, toolbox or solution that fits your needs. And also those solutions are, let's say, not case-specific, but we are testing them and assessing them under specific case studies. So yeah, for sure we can, and this is a point that we were discussing also yesterday at the internal workshop of the cluster, and discussing about potential synergies and cross-testing and cross-validation of those developed solutions, so to see also the scalability and the applicability of those developments, besides the, let's say, the limits of each project.
Yeah, I mean, if I can add to that, I mean, of course, it's a great dream to have this integrated tool, but also discussing, I mean, pretty clearly with the different cities and thinking how it is. Every city has different current system, different current management practices. These tools need to in some way interact with the systems. Cities have different needs. I mean, when we also were discussing what it means managing traffic for you, well, you know pretty well that different cities have even different opinions on what should be managed and how, what are the goals and what are the tools they may need or not. So for me, what we tried, at least with this sketch of a modular architecture, is something that, of course, I'm not saying that the ACUMEN tool is the one that should be implemented, but thinking of this modular architecture, in my opinion, is a way to go, so that having some, well, set of tools that can, well, as also Dimitri was saying, you can connect different tools from different projects and together link it together with existing systems and tools, then that's a starting point of where to go. But one solution fits all, I don't think it works at the end of the day.
And if I may add something in addition to what you said already, Claudio, in order to be able, I believe, personally, to have an integrated system at the end, we need to standardize the processes of a traffic management center and also the process of a multimodal traffic management center. I mean, you have to define different levels, including different types of solutions within the traffic management systems. Because we have different cities across Europe with different needs, with different capabilities. For example, there will be a city which does not even have a traffic management system, while other cities have even more advanced tools utilizing predictive analytics, machine learning techniques and everything. So we need to somehow standardize and set some levels within the traffic management system. So at the end, if we have that, I think that we will be able to discuss, or let's say set the basis for having an integrated system in total.
Thank you. I'm just conscious of time, and I think there is a question at the back. Yeah. Thank you. I think it's also, well, the microphone is getting, the difference between the harmonization of tools, I suppose, and applications, and we haven't really touched on the human and societal side either, how we can potentially influence those behaviors, and that definitely won't be consistent across different countries. So I think that just adds another layer of complexity into applying traffic management, how people make the decisions in the first place before they even travel. So, yeah,
thanks. So, Beatriz Martinez-Pastor from University College Dublin. I want just to follow up on the question about resilience, and I know that this is not the main topic of this project, but I agree that these type of tools, they could be essential for managing the resilience of the system. So my question is, like, most of the times we relate resilience with extreme weather events or like man-made events, but sometimes we also work with resilience on the day-to-day basis when there is construction works or like congestion. So what type of events have you been considering, if you have been considering this type of, you know, day-to-day disruptions, and at what level?
Yeah, in case of SYNCHROMODE, we are we have included a variety, let's say, both of large-scale roadworks events, especially in the South Holland case study, as I mentioned, where they have continuous infrastructure, let's say, maintenance, and also in the Thessaloniki case study, as we speak right now, and also for the next 2 years or even more, we have the construction of a new ring road on top of the existing one, which has led to the reduction of the capacity of the existing ring road, which affects has a huge impact on the network itself. So yeah, we are dealing with those issues from the SYNCHROMODE perspective.
Okay. And also you are assuming that the system can recover part of the capability, but also you are considering external probably teams for the recovery if there is any construction going on.
Yeah, and also we are also have, let's say, a tool where we are seeing how we can optimize this process of roadworks. So you can start, let's say, closing this part of the network first and not the other, because the impact will be less.
Okay.
I mean, to have also a more to provide information and some optimization to the clinics, also the strategic and planning part of the roadworks.
Thank you. I think I've got time for a very quick question. Might not be very quick, but okay. In terms of how the outcomes of the projects are going to be utilized in the future, I suppose it's a twofold question. One on the impact and how you see that. And I know you've all touched on the presentations briefly about the mid to long-term impact, but I'm just wondering what the main challenges in that being materialized, I suppose, would be. And on the other hand, on the models themselves, what are your thoughts about making them sustainable in terms of having, not from an environmental point of view, I mean from a data input point of view, because I'm just wondering how can we maintain them after the end of the projects, so it's something that can continue being utilized with potentially new data sources and keeping them up to date. Is it something you've considered yet, or?
I can answer, I think. From the beginning, I mean, when we started with the SYNCHROMODE project, the approach that we would like to follow, and I think that we are more or less in line with this vision, is that we will need to, at the end, to have a product, so the approach is more product-oriented. We also have big partners in the project, like UNEX. So we are visioning that part of those tools could be, let's say, feed their systems or their solutions at the moment, as well as, let's say, to be utilized after the end of the project duration. So yeah, we are thinking of having, as much as possible, a complete product at the end, by utilizing also the experience of those partners that are involved in the project and things like that.
Thank you.
Yeah, and similar approach we also have in ACUMEN. So the idea is, of course, that some industry partners could push forward the innovation that we developed, but also for us was important that some of the tools we are developing, like digital twin, would actually be integrated into what cities have already built as their digital twins. So we have the case of Helsinki and Athens, for example, where they have already developed some digital twin, and they are already part of their tools in their decision-making, decision support toolbox, so that our tools would actually be, the idea has been in cooperation with the cities going into the direction so that these tools, or part of them at least, would still be integrated in there, and they can then build on those for the future, and hopefully, again, adding other modules and improving our modules and so on and so forth.
And any key challenges you see with that coming into action? If not, then it sounds like it's all been very well organized and thought through.
No, it's not, but yeah, you know, if we have to talk about challenge, yeah, we will go back again to the data availability. We will turn the discussion to the standardization of those data, but we don't have the data at the end. Yeah, again, we will continue talking about integrating all those things. Yeah, but at some point we should, let's say, do the work, and as we do the work, we will see those obstacles and those challenges, and we will try to mitigate them.
Okay.
For me, one other key challenge that we are thinking more and more is how these tools can and will be used. So we are now all seeing, well, this AI boom, right? So everybody knows about ChatGPT, but I think there are not so many people that really understand what it works, how it works, and what it can do and what it cannot do. And that's something that we should also probably think in the same dimension when we think about these AI decision support, decision-making tools, right? So we also don't want I mean, if we want this to be used, users in terms of particular traffic manager need to understand what these tools can actually provide them and what is not designed for it cannot do. And so that's something we're trying to do some well, training, let's say, to the people in the city, having certain, let's say, educational, let's call them, events where we try to also to explain carefully this, because again, otherwise you risk having a tool and try to do something and get some results, and then you understand it's not exactly working because you didn't know how it works. So for us, this is also an aspect that we are touching and working on.
Thank you. Thanks. Massively important.
If I may add something, we must not forget the legislation part and changes that could or should happen towards this purpose. We have the governance framework, which has very useful, to my opinion, recommendations that would help to promote and use our results.
Excellent. Thank you. Thanks to all three of you. I think unless there is something really super quick, I'll hand back to you, Thiago, for closing the session. Thank you. Otherwise, I can stay here and keep asking questions.
Thank you very much for bringing this very interesting discussion. And thank you, everyone, for staying here until the end. We have seen, I think, a confirmation that, of course, the urban environment is very complex. There are many services, and they are trying to deal with challenges on their own. But, of course, these projects are trying to tackle some of these challenges. And I note 4 points that I think for us to bring home. On the one hand, about the data. Of course, the collection, the processing, and the use of data, of course, it's something that everybody is interested in, and also to make sure that the data that's collected has a purpose. And we are really looking forward to keep hearing also on how the models are being trained with this data, respecting the privacy and the personal, but also the business perspective. The second point is about how to use machine learning and AI for the prediction of the demand. There's a lot of ways to manage the capacity, but it's still an unknown field on how to manage and understand the demand, how this changes over time. And this moves to the third point, which is basically how to actually optimize the capacity. And here we saw about the only way to do so is really the multimodal approach. And also the coordination. Of course, we're talking about coordination about the different stakeholders involved, because with these you can deal with the normal day-to-day disruptions, but also if you can do also for the emergency situations. I think that's very key. And of course, they need to talk to each other, they need to be in the same system because they are talking about dealing with the same problems, passengers and goods being moved. And of course, the capacity of the network, it's not infinite. Then I think another point was mentioned, linked to this as well, the cooperation, is to make sure that the systems that are being developed, here we talk about, I think, CICAM for sure, I mean, electric vehicles as well, they all need infrastructure. So I think the coordination, having basically the traffic management and traffic planning, having a much better, more active role, I think that's something to keep in mind. And finally, the part of the digital twins and also any other tools that are being used for the cities. We really hope that these things will be taken up also later on. And of course, the projects are in the middle now. I would really encourage you to follow them. They have their own websites, but also don't hesitate to subscribe also to the LinkedIn, where you have the multimodal traffic management cluster, that all the projects are really actively using that. For example, the roadmap was presented there, and all the updates will be there as well. So without further ado, thank you very much once again. Lots of applause for our speakers and also our co-moderator.